Hey everybody, General Scar here, and today we're going to be talking about object pooling and how I use it in conjunction with scriptable objects. And we'll also talk a little bit about what scriptable objects are, if you don't know what they are, and what object pooling is, and how it benefits, what its benefits are as opposed to instantiation. So object pooling is a sort of a different way to do instantiation. You basically, at the start of your game, or usually, at some point in your game, you spawn a whole bunch of objects at once, and instead of instantiating them as you need them, you just move these objects and turn them on and off as needed. One of the benefits of this is that because when you instantiate something, it creates something called garbage in the code that has to do with like memory management and stuff like that. And once enough of this garbage has accumulated, Unity does something called garbage collection, which goes through and sort of clears that out. But it can also cause some lag spikes in your game when it does that. So if you have a game where you're instantiating a lot of stuff throughout it and you're having a lot of little lag spikes, it might be because of all the instantiations happening. And object pooling can help because you just do that all at once and all the garbage stuff happens at the very beginning of the game, and then we're just moving and turning on and off game objects, which isn't going to create any more garbage. So scriptable objects, I'll probably do a tutorial on these sometime down the road. If you don't know what they are, I'll just give you a really basic rundown. Scriptable objects sort of be thought of as data containers that live in your assets instead of your scenes. You can create multiple of them, and then anything that's referencing the scriptable object in your scene will have a reference to the same object. Basically, it's kind of like a static script, but they're serializable. You can create like multiple copies of them. You can like swap them out really easily and change stuff. There's just and a whole bunch of other stuff. But for this, we're just going to have it store basically the prefab we want to instantiate, the amount we want to instantiate of that prefab, and that's all we're going to mostly be storing. And we're also going to be putting some scripts in it that will let us get and send these objects to different things when they get called. So let's just get started. We're going to go and we're going to create a new C# script, and we're going to call this game object pool, because we're going to be making a pool of game objects. So we'll just call it that. Okay, so we have our game object pool, and we're going to be making this a scriptable object. So we're going to have to change mono behavior to scriptable object. So it's it's inheriting from scriptable object rather than mono behavior. So that means we can't put it in our scene, and it also means that it doesn't use our start and update functions. Scriptable objects can still use like enable and on disable, but you want to be a little bit careful with those because it like calls those while it's in the editor and stuff, not while the game is running. So you want to be, a little bit wary when using that. Anyway, we're going to have a few references. So we need a reference to, we're just going to make these public. You can make them private and then have them serializable, have them serialized in field if you want, but game object. We're going to just do this as our prefab. So this is going to be the prefab that we'll instantiate, and then later have a reference that, this is the thing that's going to be spawned in. We're going to make a queue that contains all the game objects that we have spawned. So we're going to call this spawned objs. And we're going to be using a queue instead of something like a list. And that's because queues are sort of like lists, but they can like have, you can add as many stuff to them as you want, more or less. They'll sort of dynamic. But a queue, you can only take the object at the very beginning, like at index 0 of a list. And that's all we really need. We just need to get one of these objects and just sort of cycle through all of them as we're going through. So a queue works well, and it also, I think, is a little bit faster than just using a list. And then we're going to also have, we're going to make this a private transform. We don't want this showing up in the inspector because this is going to be created in the script. This is going to be our parent. And what this will be used for is making a parent in the hierarchy for the inspector. That way, when we spawn all these objects, there's not just like hundreds of these individual objects spamming the hierarchy. They'll all be under one little parent transform, which is very nice. So we're going to create a method for spawning these objects. This is going to be the one that gets called usually at the start of the scene to spawn all of your objects. So we're going to call this spawn pool. Oh, if I can type words. Wow. Oh, brain. Okay. So we're going to do a few checks. We're going to check if spawned objects equals null, or if its count is 0. Because it can be created and have nothing in it, which would make its count be 0. And if that is true, that's when we're going to we want to make a new queue. So, oh, sorry, this, we don't want this queue to be public. We want this to be private. And we also need a public int for, we'll just call this amount. This is going to be the amount to spawn. Forgot about that one. Yeah, so I have a public int. This is the amount that's going to be spawned. This is going to be the prefab that gets spawned in. The queue we want to be private. We don't really want to do anything with it in the inspector or assign anything. We don't need to do that. All that's going to be happening when we're spawning in the pool. So if this is null, so if this hasn't been created yet, since it's private, we have to create it in the script. We'll just set it equal to a new queue of game objects. And also if its count is 0, we'll do this as well. So, and then we're going to add if our spawned objs.count is greater than or equal to our amount. So if we already have as many of these objects as we want spawned, we're not going to spawn anymore. So we're just going to return. There could be like multiple places in your scene that are trying to spawn, that are trying to start the spawning of these pools. Hopefully it's only one, but there could be a place where it's 2. And if there is, then this will just like make it so it doesn't spawn more than you set in the amount. So now if not parent, we're going to make the parent. So parent equals a new game object, and we're going to put in a name, and the name, when we use name for a scriptable object, it will just use whatever we name it in the inspector when we create it, which is very helpful. When you use like the right click rename thing, that's the name that's going to be there. And then we're going to just get the transform of this new game object that we'll create in the scene, and that's what we're going to set the parent to. And we're checking if the parent, if there is a parent already, because again, if this is getting called somewhere in the scene, we don't want to create a new parent every time it gets created. We want to put them all under the same parent. So if there's already a parent, we'll just put it under that one. So now we're going to use a while loop to spawn all these objects in. So while spawned objs.count is less than amount. So while there aren't enough in the pool, once the pool, the queue here, gets full up to the amount, then we're going to stop spawning them, basically. And again, because this could be called multiple places, using a while loop instead of like a for loop to just iterate as many times as possible will make it so it stops. So we're going to game object obj, this is going to be the object that we're going to be instantiating. We still need to instantiate it. They're just doing it at the very beginning all at once instead of throughout the scene. So we'll instantiate our prefab and we'll set its parent to our parent. So the second parameter here is a transform to parent it under, which is super helpful. So then we're also going to take our object and we're going to set it inactive. We're going to set it to false, so it turns off, so it's disabled in the scene, so you can't see it, it's not interacting with anything. And then we're going to add it to the queue. So spawn objs.inQueue obj. So in queue, we'll put it at the end of the queue. And then dequeue will take the object from the front of the queue and then also remove it from the queue, which is important later. So we have a way we can spawn all our objects. So let's do that. Let's create another script that can do that. So we'll do spawn pool. Make a new script called spawn pool. This is just going to be a mono behavior that lives in the scene, and it's going to have a public reference to our game object pool. Call this pool, and then when it starts, we're just going to do pool dot spawn pool. So when the game starts and we have this on something, it'll just create them all. So we'll call this pool spawner, drag it onto it, and then assign our thing. But oh, look at this, we don't have anything to assign to it. Why is that? Because we need to create them. I'm going to zoom in on this a little bit. So for our, because this is a scriptable object, we need a way to create it, to assign it to things in the scene. So to do that, at the top of our scriptable object, we're going to be using, in brackets, create asset menu, and then menu name, and then whatever we want the menu name. So the menu name, this is going to show up when you do in like the right click create menu, sort of where you see your C# scripts and your folders and stuff like that. That's where this is going to show up. So we can call this something like game object pool. And if we save that and let it compile, and we right click create, it shows up at the top of this menu here. This is all, you know, our scriptable objects are going to show up at the top here. You can also sort of organize it a little bit more by putting sort of slashes in front of things and having a bit of a hierarchy. So we can have, if we want to have like multiple types of object pools, we can put it under pools / game object pool. And then when we right click and create, we have this little thing with an arrow that has a game object pool, and it'll list anything we have under that slash. So we have a game object pool. So let's just call this cubes, and let's create a prefab that it can use really quick as well. So we'll create, not an empty, 3D object cube, and we'll set this to 0. We'll give it a red color, and then we'll just drag this into our assets to create a prefab of it. We can delete it from our scene, and then in our scriptable object, if we just drag this over to our prefab, and we'll set this like 100. So now this is the prefab that this is going to be spawning, and it's going to be spawning 100 of them. And in our pool spawner now, we can just drag this into our thing. We can drag this onto the script. And if we hit the button on the right, this will show all of the pools and stuff that you need. One thing I like to do with pools is just start it with a pool. Name it pool, whatever kind of pool it is, so that they're all sort of in the same spot and it's a little bit easier to find them. Because all the assets, all the scriptable objects sort of have the same icon in the assets thing, so which ones do what can get a little confusing, so just sort of organizing it by name like that is a little helpful. So now if we start the game, everything is assigned, everything should work. We should see, yes, here, pool cubes has come, and there's a lot of these now. And so we can just enable them and disable them, and we just got a bunch of cubes. One thing I want to do, let's just open up our cube prefab. I want to add a rigid body to this so we can throw it around because it looks nice. So let's save that. So let's go back to our game object pool script here, and we're going to add another method here that will let us get a game object from this pool from another script. So public game object get pooled object, and we're going to be has a game object instead of like void because we're returning a game object, one of the game objects from the pool. So first we want to check if there is stuff in the queue, if the queue is active, if there, if it's anything like that, because if you don't, like I said, this could be called in the middle of the scene and it'll still work. There might be a little bit of a lag because of that, because it's instantiating a lot of objects at once, but it can still work. We just want to add a check to make sure that if something is trying to get an object from this pool, if the pool isn't actually there, if there's like nothing that's been spawned, we want to spawn it in first. So we're going to check that if spawn pool is null or spawned objs.count equals 0. So if there's nothing in the queue, then we're going to spawn our pool. So this will spawn all our objects and stuff like that. And then I also like to add just a little bit debug log warning here. And this just to like give us a little reminders, like, hey, you should probably put this somewhere so it doesn't spawn in the middle of the game to create any lag. So we're going to use some string formatting. So if you hit the $, you can do some cool stuff. So like if you put curly braces and whatever's inside of these curly braces, you can put like a variable. So like our name of the scriptable object, and it basically concatenates it without having to do all the pluses and stuff like that. So we'll just call this, so it's like the name spawned mid-game. Consider adding it. Consider spawning it at the start of the game. So now whenever something spawns in the middle of the game, you just get a little console thing that's like, hey, maybe put this somewhere else. It's not going to break the game, but it can help make it not lag so much. So once we have that, everything is spawned. We know that it's spawned. We're going to get a reference to a game object from our queue of stuff. So our spawned objs.dequeue, and this will just get the first object at like the beginning of the queue. And it'll get a reference to it, but it'll also remove it from the queue. So that the next object in line gets pushed forward. So because of that, we want to put it in the back of the queue. So we have a constant list, a constant stream of things going through. So we never run out of these objects, more or less. So we're going to stick it at the back of the queue. So spawned objs dot enqueue obj. So we take it from the front and we stick it in the back, but we still have a reference to it here, so we can do stuff with it. So we can set it active, obj.setActive. True, and then we'll just return this. Return our obj. So we get the game object from the queue, we move it to the back of the queue so that it doesn't get called until it goes through a whole loop of all the other game objects. We set it active, and then we send it back to whatever's calling this. One other thing that's very helpful that we can do, we can use it as just this and then handle like the positioning and stuff like that in the other scripts, but often I find that it's easier to do it from here. So if we just get like a vector3 new pos and a quaternion new rot for new rotation. So new position, new rotation. This is where we want, this is like the place in the rotation that we want these objects to spawn in at. So you can handle it per script, but I think it's easier to just have it in this method. You can also have overrides that don't have these and just return it, stuff like that. So obj.transform.set, transform.position equals new pos, and then obj.rotation, transform.rotation equals new rot. So now when we call it, we put in a rotation, we put in a position and a rotation, and it'll just spawn them in there. Sweet. So that's basically all we need to do for this script. So one other thing, sometimes when you're instantiating stuff, you want stuff to be running like on start or on enable. And one way we can enable our script to make sure that that's happening is before we send it back, because we're turning it active here. So this is where it would start doing the things on start or on enable. It would do it here, but only if it's disabled first. And right now we have it set active, but it's not going to become inactive after that unless there's like a separate script on the object. So we can actually just obj.setActive false. So we just turn it off before we turn it back on. So it's when it spawns back in, it'll still do all the stuff on start. So that's just a little thing to make that work a little bit more consistently. So that's all we need to do for our game object pool, really. So now let's create another script that will use this game object pool. So we'll just call this a fountain, pool fountain, and this will just be a very simple script where we're just going to be constantly spawning these objects, basically. And we're going to be using a coroutine. So private I enumerator, there it is. And we'll just call this spawn. And with the coroutine, we can just have it spawn every some amount of seconds. So we'll just add a while loop. And then a coroutine, this is a very important thing about coroutines. It needs a return statement. So yield, return, whatever. We're going to be using a new wait for seconds. There's a lot of things you could do with these, like wait for update or just null. But we're going to use wait for seconds so we can put an amount of seconds we want to wait before it spawns the next one. So we'll have that as a float up here. Time equals 0.1 f. So every 10th of a second, we'll just put that in here, spawn time. It's going to spawn a thing in the while loop. Well, more or less, it's going to go through this loop. It's going to do what's ever in it. It's going to wait a 10th of a second, and then it's going to do that again. It's going to wait a 10th of a second. It's going to do it again. So if you don't have this return statement in here, the game will freeze when you start the game. So you want to be careful that you have your yield return statements if you're doing stuff in a while loop with an I enumerator that doesn't have like an exit statement like this. Just FYI. Okay, so now we need a reference to our game object pool. Our pool, and then on start, we're just going to start our coroutine. Start the coroutine, and in our coroutine is where we're going to be calling the game object. So pool. So actually, we need a reference to a game object equals pool dot get pooled object. So this will set obj equal to whatever object is in our pool. Sweet. We also need to put in our position and stuff like that. So transform.position, transform.rotation. And then also for this, I want to have it so it shoots the rigid bodies up in the air. So we need a reference to the rigid body RB equals obj.get component rigid body. That's not it. Rigid body. Sometime autocomplete works better than other times. There we go. Rigid body. And then if RB, so if in fact it does have a rigid body add force, transform.up, and then we'll add a force value up here. So public float force, multiply it by force, so it'll send it upwards by however much force we have. And that should be all we need to do in here. So if we, oh, one other thing actually, in our spawn pool script, instead of doing this on start, we probably want to do this on awake. So that way we make sure that everything is spawned. So awake gets called before start. So then we spawn everything in awake just to make sure that when we start it in start, it's not gonna do it, without having spawned it first, more or less. It'll still work if it does, but just to be a little bit safer, I guess. So we'll create a new object. I'll call this fountain. I think I spelled that wrong. Set this to just one above. And one thing about empty game objects, if you want to be able to actually see them where they are located in the scene, if you hit this little cube thing to the very left of the name, you can choose sort of a label for it. So you can have a label so it shows the name of it, or you can have just a little marker so you know where it is, which is nice. And then I'm going to be making this bigger. Let's save our scene and hit play. And so now a whole bunch of cubes should spawn if we ever actually assigned our script. So pool fountain, and then we need to assign our pool. And we hit play. And boom, we've just got a whole bunch of stuff spawning in. So one thing you'll also notice about this sort of a system is that once it's reached the end of the queue, some of the objects are just starting to disappear now because there's only 100 of them. So once it gets through 100 of them, it gets the oldest one that's been spawned basically and moves it. So there's only a limited amount of these objects that it can reference, which is good because it's not going to increase the amount of memory. There's not going to be anything where you just constantly spawning tons and tons of new stuff and it's going to be lagging the game. It's always going to be sort of the same performance no matter how these objects are being spawned, which is nice. But there are some ways you can get around that. So that is how you can use scriptable objects and object pooling and how I sort of use them. It's very nice because you can go in and change what sort of a prefab or the amount or anything inside of these scriptable objects in the assets, and then it'll change it for anything anywhere in your project, not just your scene. So you don't have to worry about changing, constantly updating stuff per scene. It's going to be a per project thing, which is very nice. So the GitHub repo for this project is going to be in the description below if you want to check it out, look at some of the scripts, stuff like that. So I hope you learned something new. Thanks for watching.